In addition to calculating a confidence interval, just to have the confidence interval, we can also calculate a confidence interval in order to test some claim. And that's what we're doing in these exercises in 3.10. The process that we use to construct the confidence interval is just the same as it was in 3.9. But now we're taking an additional step and testing an assumption. So we still have information about a sample, but now instead of just constructing a confidence interval, we're using the confidence interval to see whether or not it's still the case that 33% of all sales transactions are in cash. Right, so we start the same way. In fact, the P, A, N, and I are exactly the same. So our parameter is P, which is the percentage of all US sales transactions that are in cash. This is still qualitative data, and we need to check whether the number of yes responses is at least 10, the number of no responses is at least 10, and the population is large relative to the sample. So since we're scrolling, I'm going to write down the number of yes answers, the number of no answers, the sample size, and just so I have it handy, the confidence level we want. So there were 383 cash transactions in a sample of 1,500. And we're going to want a confidence level of 92%. This is the number of yes answers, 383. It's greater than or equal to 10. This is the number of no answers. That'll be 1,500 minus 383. That'll be 1,117. Again, greater than or equal to 10. We don't know the population, so we'll use a million. 20n is 20 times 1,500 is 30,000. And I just used a calculator off screen for that. And indeed, the population is greater than or equal to that. We want to take a 1 proportion z interval. Our point estimate, p hat, is the 383 cash transactions over the 1,500 transactions in the sample. The interval estimate for our parameter, p, here we use the calculator, stat, tests, 1 proportion z interval. We had 383 yes answers out of a sample size of 1,500, and our confidence level is 92%, so we'll say 0.92, calculate. We have 0.2, 3, the next digit is a 5, and after that we have a 6. So that means we round up. And then 0.275, and the next digit is a 0, so we round down, and we submit. Okay, so the difference between this and the problems in 3.9 is the conclusion. The first part is the same. Our confidence level was 92, so we're 92% confident that the parameter, the percentage of US sales transactions that are in cash, is between this number as a percent, 23.6%, and this number as a percent, 27.5%. And now here comes the new thing. So we'll notice, here's what we're thinking. Imagine our friend the number line. We have 23.6% and 27.5%. That's our confidence interval in here. And then over here somewhere is 33%. We're 92% confident that the percent of all transactions that are cash is in that interval somewhere. But that entire interval is less than 33. The entire confidence interval is below the claimed value of 33. What does that mean? We think that the actual proportion is in that interval. 33 is not in the interval. We think that the actual proportion is probably less than 33. There is significant evidence that the percentage of all US sales transactions is smaller than the claimed value. So that last conclusion step is to say, we think the true value is in the interval. Everything in the interval is less than 33, so we think the true value is less than 33. Right, and there are 3 ways that this can go down. And it matches the options that we have here. Right? We might have everything in the interval is less than the claimed value. And I'm going to talk in terms of this specific example. The whole interval is below 33. Right? Which is the claimed value. It wouldn't have to be 33. It could be 89 or whatever. Then we have evidence that the true value is below 33. Because we think that the true value is in the interval. Or it might be the other way around. We might have the whole interval is above 33. In that case, we would have evidence that the true value is above 33. And then the third thing that can happen, our interpretation is a little bit different, right? We might have 33 is in the interval. Right, so for example, we might get an interval that looks like this. Right. We might have 33 be one of the numbers that's in the interval. Well, that means that for all we know, 33 could be the true value. But it could be any other number in the interval, right? So for example, it could be like 34.6, right? When we find 33 in the interval, that doesn't mean that 33 really is the true value. It could be anything in that interval. What we say is, there is no evidence that the value is not 33. Right? So if the claimed value is outside the interval, we say that there is evidence that the claimed value is wrong. If the claimed value, let me say that again. If the claimed value is outside the interval, we say that there is evidence that the claim is wrong. But if the claimed value is inside the interval, we don't say that's evidence that the claim is right. We say that there's no evidence that the claim is wrong. And then typically that means we continue believing the claim because we thought the claim was true for some reason before. But it's very important to be careful with that when you're looking at statistical data, right? If you find that the claimed value is in the interval, that doesn't really tell you anything that you didn't know before.